Dear students, welcome back. In this lecture, we'll discuss the basic operating principle and construction of an induction machine. An induction machine consists of two main parts, the stator and the rotor. And the two are separated by a small distance or gap known as air gap to allow the free motion of the rotor. Now, as far as the stator is concerned, the stator it consists of a cylindrical, hollow, laminated core of iron which houses a three-phase winding placed in slots on its inner surface. So the first thing that the stator has, it has a stator core, a magnetic core, which is cylindrical in shape and is hollow, and it is laminated, meaning thereby that it is made up of a large number of laminations, thin laminations placed one above the other, and that core is made up of iron. And then we place on the inner surface slots are cut and a three-phase winding is placed in the slots. Now this winding, when it is supplied from an external source, and as the currents flow in the winding, it results in production of a rotating magnetic field. So the currents are supplied from an external source, currents from an external source, and these currents are three-phase currents. It will result in production of a rotating magnetic field. Magnetic field in the air gap. Of the machine. Now, like the stator, the rotor also consists of an iron core. And the core is cylindrical, consists of a cylindrical iron core, which again houses a winding, in slots on its surface. Now, the rotor winding is not supplied from an external source. The rotor winding is not connected to an external source, but the rotor currents are produced by induction due to the rotating magnetic field. So what happens? The currents in the rotor windings, they are not supplied from an external source, but those are produced by induction due to the rotating magnetic field. As the magnetic field rotates, it cuts the rotor conductors, and therefore an EMF is induced, and as the circuit is complete, currents are also induced in the rotor circuit. We have current carrying conductors in a magnetic field. The interaction of the rotor currents with the rotating magnetic field results in production of a torque in the direction of the rotating magnetic field. We'll discuss this in more detail later. We'll see that the direction of the torque produced is same as the direction of the rotating magnetic field. Now, since the currents in the rotor are produced due to induction, that's why the name induction machines for this class of machines. Now, since the currents in the rotor are produced due to induction, for induction action to occur, there has to be a relative motion between the rotor conductors and the rotating magnetic field, and therefore the speed of the rotor can never be equal to the speed of the rotating magnetic field. Let's write it here. For induction to occur, the speed of the rotor can never be equal to the speed of the rotating magnetic field. And we know the speed of the rotating magnetic field is called as synchronous speed. Synchronous speed. Now, since the speed of such a machine can never be equal to synchronous speed, therefore these machines are also called as asynchronous machines. This is in order to distinguish these machines from another class of AC machines, which are known as synchronous machines, which we'll be dealing with towards the end of this course. Now, there are in fact two types of rotor construction employed in induction machines, and based on the rotor construction, the machines are named accordingly. Let's discuss the two types of rotor constructions. The first type of rotor construction is known as squirrel cage rotor. This type of rotor consists of bars, thick bars, of high conductivity material. Like copper or aluminum, placed in slots on the surface of the rotor. So what we do is, first thick bars of high conductivity material are placed in slots. There are slots on the surface of the rotor, and thick bars are placed in those slots. The rotor bars are then, these are short circuited at both ends. You have bars in the slots all along the surface, and the ends are yet free. Then at the two ends of the rotor, the bars are shorted together by thick circular rings of the same material as the rotor bars. The rotor bars are shorted at both ends by thick circular rings of the same material as the rotor bars. Let me draw a diagram here showing the details. The shaft. So in this diagram we can see these are the rotor bars, these shown here on one side. The bars are visible, and on the two sides there are two circular rings which are known as end rings, and you can see only, you cannot see bars if you have you look from the surface of the rotor. You cannot see the bars themselves, but the bars are inside, and only small openings of the slots can be seen. So these are the rotor bars here. Rotor bars. This is the rotor core. And these two circular structures are the end rings. This and this one. This is one end ring, and another end ring is on this side, and this is the shaft of the machine. So this winding consists of thick bars of conducting material which are placed in slots on the surface of the rotor, and then the bars are shorted at two ends by circular rings, thick circular rings of the same material as the rotor bars. Now, as far as this rotor construction is concerned, we can see that the winding, if we consider only the winding of this machine, the winding resembles a squirrel cage. The winding resembles a squirrel cage, and that's why the name squirrel cage rotor. And a motor which uses a squirrel cage rotor is known as a squirrel cage induction motor. Squirrel cage induction motor. And it is abbreviated as SCIIM. So we see that a squirrel cage rotor is simple in construction. It is cheap also and robust, or you can say rugged. And therefore it needs no maintenance. One more advantage of this rotor is that it can adjust to any number of poles on the stator. You know that the stator winding will be wound for a particular number of poles, but this is a simple structure. You have bars in the rotor which are shorted at both ends. There is no consideration of poles as far as this winding is concerned, and it automatically adjusts itself to the number of poles on the stator. It adjusts to any number of poles on the stator. But this winding has a drawback, that since the rotor winding is not accessible externally, it is shorted inside, you cannot access the rotor winding externally. The rotor winding is not accessible externally, and hence the starting and speed control of a squirrel cage induction motor is not easy. Now, although I have rubbed off the squirrel cage rotor construction here, you must have seen that the rotor bars are not parallel with the axis of the rotor. The bars are skewed by a small angle, and this is done in order to reduce the effect of harmonics or harmonic torques in the machine, and to prevent the locking between the stator and the rotor. Now, the second construction employed for the rotor of an induction machine is known as wound rotor construction, and a motor that employs such a rotor will be called as a wound rotor induction motor. Wound rotor induction motor. and abbreviated as WRIN. A wound rotor consists of a well-designed three-phase winding placed in rotor slots. This winding is similar to the winding on the stator. And since the stator winding is wound for a particular number of poles, we have a three-phase winding on the rotor. Therefore, this winding should also be wound for a particular number of poles. And for satisfactory operation of a machine, the rotor winding must be wound for the same number of poles as the number of poles on the stator. Wound for the same number of poles as the stator winding. Now we have three-phase windings on the rotor, and there will be 6 terminals of the three-phase windings. The windings are internally connected in a Y fashion by connecting one terminal of each of the 3 phases together to form a neutral point. And once it is connected in Y, we have 3 terminals available. These 3 terminals are brought out along the rotor shaft and are connected to 3 silk rings on the rotor shaft. These 3 silk rings are well insulated from one another and from the rotor shaft, so that there is no short circuiting between these. And then brushes make sliding contact with the silk rings, and those make the rotor circuit accessible external to an external circuit. Let us draw the schematic diagram of such a rotor winding. We have on the rotor, we have a 3-phase winding which is connected in Y. So we have 3-phase winding which is connected in a Y. We have a neutral point and 3 terminals are brought out, and these are then taken along the rotor shaft and connected to 3 silk rings on the rotor shaft, and the 3 silk rings are well insulated from one another and from the shaft. So this is the rotor of the machine. And then there are 3 silk rings, 3 brushes which make sliding contact with the 3 silk rings, and therefore through these 3 silk rings the rotor winding is accessible externally, and therefore an external impedance can be connected in series with the rotor circuit. And by connecting a suitable impedance in series with the rotor circuit, the starting and the running performance of the machine can be controlled. by connecting an external impedance or a suitable external impedance, a suitable external impedance in series with the rotor circuit, the starting and running characteristics of the motor can be controlled. Now, since we make use of silk rings in this motor, such a motor is a motor which employs a wound rotor is also known as silk ring induction motor. Silk ring induction motor. And abbreviated as SRIN. Therefore, this motor has two names: wound rotor induction motor or silk ring induction motor. Now, we have seen that by inserting a suitable impedance in series with the rotor circuit, we can alter the starting and running performance of the machine. Therefore, this provides a simple method of starting and speed control for such motors. However, as far as the rotor construction is concerned, this rotor construction is complex construction, and therefore it is not inexpensive, it is expensive and not as robust as spiral cage rotor. And frequent maintenance may be required because you have sliding contact with the brushes, so therefore it may needs frequent maintenance. And so we'll conclude this lecture here. Thank you.